Hello and welcome to SQA Higher Maths, further calculus or applying differential calculus. We're going to be looking at maximum and minimum values within a closed interval. Okay, so we already know how to find a maximum and minimum turning point or a point of inflection as well. So if you've forgotten how to do that, or if you're not quite sure, please go have a look at lesson 7 from the differentiation playlist again, because you really need to know how to do that properly before attempting these questions. Okay, so strongly advise you to do that in advance, or even if you just want a quick reminder of what's going on with it. Right, so what we're looking for here is the maximum and minimum value within the domain of -2 to 6. So I want to know the maximum and minimum value. What does that mean? That's just the y values. So basically, when is the highest point on the curve between x is -2 and x is 6, and when is the lowest point or the minimum value on the curve? So here we can see the maximum value occurs here. The minimum value, sometimes it's the minimum turning point, sometimes it is not. So here we'll notice the minimum point, the minimum value is actually below the minimum turning point. And if we extended the domain, so here we have x equals -2. So if we kind of drag this down to about here, we could see this curve would go up and it would be much higher than the maximum turning point. So if we're trying to find a maximum and minimum value within a given domain, what we need to do is to find the stationary points. Again, look at lesson 7 on the differentiation playlist for a recap of that. And then we also need to find the y coordinates at each end of the interval. So here I would substitute x equals -2 into y equals, or f of x equals if it were given it, and also substitute in 6. Okay. So note that the minimum value occurs at one of the endpoints in this example. It is important to check for this. So we do need to check the endpoints, which is what I was just saying. Substitute -2 and 6 into y equals. Okay, I will do an example in a separate video. That's just an introduction to what we're finding out.